We're going to do a little review of how you write a lab report, in particular the conclusion, before we look at your pH lab on Wednesday. In your conclusion, you're going to use a claim, you're going to use evidence to support the claim, and you're going to give some scientific explanations, which is the reasoning as to why and how your evidence supports your claim. First, we need to examine the whole concept of claim. A claim in science is very different from a claim that you might make if you're in an accident and you file an insurance claim. It would be a little bit different than what you would do if you were going to claim something happened. In science, a claim has got to have evidence to support it. So when you write a claim, it will be very short. It will be a sentence that you write after you look at your data. Be a short sentence that you write after you look at your data, and you're saying, well, the data is clearly pointing to something going up as something goes up. You're looking for a relationship there. So you're writing a short sentence that states what happened. And you're going to write from your data. After we go through this, we're going to take a look at an example of how this might actually look in a lab report, in a very simple lab report. But for now, we want to just look at what you're going to be doing. You need to look at your investigative question. That can be very, very helpful as you are trying to answer that question, because the claim answers the question. Your claim, if you are using an experiment with variables, would have to identify the independent and the dependent variables. So if you were going to say that as you increase the temperature, the volume increases as well, temperature would be the independent variable because you are changing this. And the dependent variable changes as a result. Okay? And you're going to describe the relationship between them as temperature increased, volume increased. So you're going to just restate what you actually found. The evidence, then, you're going to describe many data points. So what you may not do is say, see the data table. What you must do is you must say, at 25 degrees Celsius, the volume of the balloon was 2.20 liters. That's 1 point, but you need more of those points to solidify what you're trying to say. You will, if you measured any numbers, if you have any numbers written down, you must include the number values. You can't just say, as one got bigger, the other got bigger, because we don't know what one and the other is, and we don't know how much is bigger. Okay? You must include units with your numbers so that we know that you're talking about temperature and volume. You would want to describe your graph and how you maybe used those variables. Your graph should have your variables in that. And you want to look at the trends in the graph and describe them. And here you can say, as temperature increased, volume also increased. You can say that now that you have some numbers to back that up. In your reason, you should be able to explain what the evidence shows. My data show that as temperature increases, the volume also increases. So now you're going to write your explanations. You've not done any explaining so far. Not done any explanation so far. You're going to do that in your reason. You can reference your claim and you can say, here's what I said, here's what I originally said in my claim, and that was right here. So you're going to be restating that. You're going to include the scientific concepts. So if we were looking at increasing the temperature of a balloon and seeing the balloon expand and get larger, the volume of the balloon, we could say that the particles were moving faster, the particles of air. They were bumping into one another, they were moving faster, and they were bumping into the walls of the balloon more quickly. So you're going to use the science that you know, the scientific concepts that explain what's happening, and you're going to explain anything that's related. So this is going to be a little bit longer. Your claim might be a sentence. Your evidence is going to be several sentences, probably, to refer to all of your data points. And then your reason is going to be an explanation of those. You also want to include an alternate explanation. Well, I'm confident that I explained in this way, but here's another possible explanation. Now, don't go fishing for this. If it's a lab that needs an alternate explanation, it'll be pretty obvious, or you can ask. Something else could have happened. Okay. So an I wonder statement, further questions. I wonder what would happen if we had. I wonder what would happen if we had done this. Or I wonder what would happen if we had done that. And possible limitations often could be experimental error, or more commonly, things you could not control. Experimental error are things that happened that there was nothing you could have done anything about. These are experimental error. Okay? A limitation would be, well, we simply weren't able to measure to the nearest 10,000th of a gram, so we couldn't get any more precise measurements than we have. Or we couldn't get the flask to be cool enough because we only had ice and salt. It would only go down to negative 15 degrees Celsius. We couldn't get it down to negative 30. So limitation is something that you just physically couldn't do. Here's what you will not mention. Human error. There's no such thing in science as human error, contrary to what you may have been told in the past. There are mistakes. In that case, you need to go back and you need to redo that. So saying, oh, we calculated wrong or we measured wrong doesn't cut it. If that happened, you need to go back and redo the experiment. You don't need to just say, well, all of our stuff could be wrong and we really don't care. You've got to go back and redo it. So in looking at this, you will have a claim, which is a short sentence that tells what you actually found. Well, we were looking to find out if the volume of a balloon increased as you increase the temperature. We found that the volume of a balloon increases as you increase the temperature. In your evidence, you will use your data points. You will say, at 25 degrees Celsius, the balloon was this. At 30 degrees Celsius, the volume of the balloon was this. And you will continue with those until you have given enough of your data points and described what's happening on the graph. Your reason is going to explain why that happens. You're going to explain, here is where you use your science knowledge, maybe what you read before you did the lab, what we did in class before that, or maybe what you have looked up and written in your introduction. Your rebuttal should always include alternate explanation, if there is one, an I wonder statement, and you can almost always put that in. And possible limitations are things that, well, we realized that we could only be this precise or this accurate, and also time is never a limitation. You have enough time in these labs. We've done them for years, and we know how long it takes to do them, and if you didn't finish, maybe you weren't working as efficiently as you should have. So you need to maybe spend some time on your own getting that finished up. But if you put either of these two things, human error or time, as a limitation, I will stop reading immediately and you will do a rewrite because they're not part of science. So in general, in your writing, pay attention to this. Try not to use pronouns, they, it, then. So if you say, it increased because it increased, what was it? We don't know. We don't know. We also don't prove anything in science. Science does not prove. Science just collects evidence to support a particular claim. If that experiment had been done with slightly different variables under slightly different conditions, yeah, you might find something very, very different. And that's why you're talking about all of those conditions, okay? Your evidence might support your claim, but you don't prove. Limitations, sources of error and limitations you're going to describe. Human error is not a valid source of experimental error. If you made a mistake, you made a mistake, but it's not human error. And we don't want to say we may have measured wrong or our calculations may have been off. Off is not a valid scientific term either, so don't use that word unless you're mentioning that you happen to push your test tubes off the edge of the counter. Oh wait, your lab partner did that. That's why you have a lab partner, so you can blame things on them. So you're going to now look at some examples of this in the next video and see how we're going to actually write a claim, evidence, and reason from some evidence.